All right, in this section, we're going to go back over LU decomposition, which we've seen before. You can write any square matrix as a product of a lower triangular times the upper triangular matrix. Here's a representation of lower triangular. All the entries above the diagonal are 0. Upper triangular, all the entries below the diagonal are 0. The reason why LU is used is once you write it in this form, you can facilitate the solution of linear equations. For example, if I have an equation mx equals v, where m is upper triangular, I can do what's known as back substitution. Notice that this system of equations can be represented as ax plus by equals 1, cy equals e. But cy equals e can be solved immediately, and once I know what y is, I can plug y into the first equation and solve it. Okay, so upper triangular matrices represent a system of linear equations that's easy to solve. The same with lower triangular. You can also solve that easily. All right, here I have a system of linear equations represented by a lower triangular. First equation is x equals d, and then if x equals d, then I can plug x in for the other equations here, right? This is ax plus y equals e, so I can write y equals e minus ax, and that gives me y. This is bx plus cy plus z equals f, but I know what x is and y is. I can substitute and get z. So this is called forward substitution. All right. So basically, this next section systematizes the example that we just saw. If I have a matrix that's written in LU form and I want to solve mx equals v, I can do this in two stages. I can think of this equation here as L times ux equals v. Now, since I know L and I know v, I can solve for this ux. All right, so that's what we say here. We're representing ux by w. All right, so you can consider this equation here as L times w equals v. Since I know L and I know v, L is lower triangular, then by the forward substitution method that we just saw, I can solve for w. Once I know w, then I know that w equals ux. Now I know w and I know u, and I can solve for x by backward substitution. All right? So here's an example. You can work through this and see how it works. Okay. And there's the summary right here. Okay.